Assalamu alaikum dear students. Unit है थर्मोडाइनमिक्स और आज का टॉपिक जो है वो है इंथैल्पी एंड इंथैल्पी चेंज। सबसे पहले हम डिस्कस करेंगे व्हाट डू यू मीन बाय इंथैल्पी। नंबर फर्स्ट है दैट इज इंथैल्पी। इंथैल्पी का दूसरा नाम जो है दैट इज आल्सो कॉल्ड एज हीट कंटेंट। And it is denoted by the letter H. It is denoted by H. Now what is enthalpy or what is heat content? We know that हमें पता है कि every substance जो होता है that is associated or every system है associated with certain definite amount of energy जो उसमें store होती है energy, उस stored amount of energy को हम कहते हैं internal energy, and that internal energy which is available for conversion into the heat that is called as the heat content. Suppose हमारे पास एक system है, we have a system A and it has its internal energy, suppose that is E, its internal energy is E, or its internal energy is U, and that amount, this internal energy which is stored in the system A, which is available for conversion into the heat, that amount of that is called as the heat content, or that's called as the enthalpy, which is internal energy which is available for conversion into heat. वो amount of energy, internal energy which is available for conversion into the heat, that is called as the enthalpy, or that's called as the heat content. So we have the definition of the enthalpy. It is that every substance is associated, or every system has a stored amount of energy in it, and that amount of the energy which is available for conversion into the heat, that is called as the enthalpy, or that's called as the heat content. So we have the definition of the enthalpy. Definition of the enthalpy is enthalpy. Enthalpy, the amount of the internal energy available for conversion into the heat is called enthalpy. Enthalpy or heat content, and denoted by H, and is denoted by H. So enthalpy है क्या? It is basically वो internal amount of energy जो store होती है किसी भी system में, which is converted into the energy into the heat, that is called as the enthalpy. Now in mathematically this enthalpy it is given as so we have the mathematical expression for the enthalpy, that's enthalpy is equal to H is equal to E plus PV, where what is H? H is enthalpy, E is internal energy, P is pressure, and V is volume. So this is the mathematical expression for the enthalpy, and enthalpy is given as the internal energy plus pressure volume work done. So we also know according to the, suppose if we have a system having the internal energy, suppose we have a system A, its internal energy is, we have a system A, its internal energy is E1, and its volume is suppose V1, and the process that's carried out at the pressure को हम constant करते हैं. And now if it is converted into the another system, that is the B system, B system, its internal energy is E2 and volume is V2. And let the enthalpy of the system E, that's called the H1, and enthalpy of the system, that is called B system, that is called the H2. So we have for the A system, H1 enthalpy is equal to E1 plus PV1, and for the system B we have H2, that is equal to E2 plus PV2 for the system is. Now what is the change in the enthalpy? Change in enthalpy is given as del H, that is equal to H2 minus H1. This is change in enthalpy, and this change in enthalpy is equal to amount, this is equal to the change in enthalpy is equal to the enthalpy of the final state minus enthalpy of the initial state. अब हम derive करेंगे expression for the change in enthalpy. So we have in the mathematical expression we said that enthalpy is equal to E plus PV, where E is the internal energy, P is pressure, and V is volume, and H is enthalpy. Enthalpy of the system, that is equal to the H1 is equal to enthalpy of the system A, that's called H1. Its internal energy is E1, V is the volume. Similarly, we have the B system, its internal energy, volume, and the enthalpy. So we have the change in the enthalpy, that is given as H2 is equal del H is equal to H2 minus H1. Now we have to derive the expression for the change in enthalpy. Expression for the change in enthalpy, that is equal to expression for change in enthalpy. We know that हमें पता है, know that according to first of thermodynamics, according to first law of thermodynamics, according to first of thermodynamics हमें पता है what, that del E is equal to Q plus W. ये हमें पता है, that is the change in the internal energy, that is equal to the amount of the heat evolved or absorbed by the system, and that is W is the work of expansion, or it may be the work of contraction. So we have expression from the first of thermodynamics, that is del E is equal to Q plus W, or we can also write it, this is our equation first. We can also write it as del E, इसको यहाँ लाएंगे W को, माइनस W इज इक्वल टू Q, और Q इज इक्वल टू del E plus the minus W. And for work of expansion, के लिए W किसके बराबर है, माइनस P del V. सो हम इस वैल्यू को सब्स्टिट्यूट करेंगे इन और दिस इज आवर इक्वेशन सेकंड. बेसिकली हमें क्या करना है, डिराइव करनी है हमें एक्सप्रेशन फॉर द चेंज इन एंथैल्पी. फॉर दैट वेरी पर्पस वी से दैट फॉर अकॉर्डिंग टू द फर्स्ट लॉ ऑफ थर्मोडायनामिक्स हमें पता है चेंज इन इंटरनल एनर्जी इज इक्वल टू Q प्लस W. अब W को हमने यहाँ लाया, इट बिकम्स माइनस W इज इक्वल टू Q. And for work of expansion we have W is equal to minus P del V. So हम अब W का वैल्यू सब्स्टिट्यूट करेंगे इन इक्वेशन सेकंड में, तो we have Q is equal to del E minus into this minus, and W for W is equal to minus P del V minus P del V. So Q is equal to del E minus minus, that's plus P del V. So if the process is carried out at the constant pressure, we say that QP is equal to del E plus P del V. Now what is this del E? Del E किसके बराबर है, del E is equal to E2 minus E1. del V किसके बराबर है, V2 minus V1. अब हम ये दो वैल्यूज इस इक्वेशन थर्ड में सब्स्टिट्यूट करेंगे, दिस आवर इक्वेशन थर्ड. हमने क्या किया, हमने सिंपल सा यहाँ पर एक्सप्रेशन ली फ्रॉम द फर्स्ट ऑफ थर्मोडायनेमिक्स, देन वी substitute the value of the work of expansion in the equation, we get that is q is equal to del E माइनस माइनस प्लस पी डेल वी, एंड फिर हमने यहाँ पर हम वैल्यू सब्स्टिट्यूट करने जा रहे हैं डेल ई का और डेल वी का. सो वी हैव हियर क्यू पी इज इक्वल टू del E के बदले that is E2 minus E1 plus P into V2 minus V1. Now we have QP is equal to E2 minus E1 minus plus into that's plus P V2 plus into minus PV1. अब QP is equal to E2, इसको यहाँ लाएंगे that's plus PV2 ब्रैकेट में रखेंगे प्लस it is minus E1 minus PV1. अब यहाँ पर इस माइनस को हम बाहर निकालेंगे that's QP is equal to E2 plus PV2 minus into E1 minus into plus, that's called the minus into this is plus here PV1. Why plus? Because plus into minus that becomes minus. So we have here QP is equal to E2 plus PV2 किसके बराबर है? That's called the, basically we have H is equal to E plus PV, and if this is E2 and volume is V2, then enthalpy becomes H2. So we have E2 plus PV2, that's called the H2, minus E1 PV1, that's called the H1. So we have QP is equal to H2 minus H1 and QP is equal to del H. So this is the expression for the change in enthalpy. So change in enthalpy may be defined as the amount of the heat, either it is evolved or it is absorbed by the system at constant pressure. That's called as the enthalpy change. So we have a change in enthalpy. It may also be, it may be defined, that's change in enthalpy may be defined as the amount of heat evolved or absorbed by the system at constant pressure is called as the enthalpy change. So we have the expression for the enthalpy change, that enthalpy change is equal to, either it is equal to del that is equal to the QP is equal to del H, or del H is equal to del H is equal to, यहाँ पर हमने पहले ये एक्सप्रेशन डिराइव की फ्रॉम द फर्स्ट ऑफ थर्मोडायनेमिक्स, दैट इज डेल्टा H is equal to change in enthalpy is equal to del E plus P del V. So we have the two expressions for the change in enthalpy, that is enthalpy is equal to the amount of heat evolved or absorbed by the system at constant pressure, or it is equal to the del E plus P del V. So we can also define here the change in enthalpy as, it may be defined as sum of the increase in the internal energy plus pressure volume work done. So enthalpy change may be also defined, either we can define the enthalpy change as amount of heat evolved or absorbed by the system at constant pressure, or we can say it is the sum of, that is the sum of internal energy and the pressure volume work done. So it may also be defined as the sum of increase in internal energy and the pressure volume work done. So this is the expression for the enthalpy and the enthalpy change. We have the enthalpy के लिए expression क्या है? That is H is equal to E plus PV. This is for the enthalpy, and for the enthalpy change, del H is equal to QP. This is the expression for the enthalpy change, or del H is equal to del E plus P del V. This is the change in the enthalpy. So we have the two expressions for the change in enthalpy. Either it is equal to the QP del H is equal to QP, or del H is equal to E plus del E plus P del V. Or we can also write it as del H के बदले हम यहाँ पर लिखेंगे QP. So we have QP is equal to QP किसके बराबर? del H के बदले QP is equal to del E plus P del V. These are the expressions for the change in enthalpy. And what is enthalpy? So what is enthalpy? Enthalpy is the amount of the energy, the available amount of the energy, which is available amount of energy that is converted into the heat, is called as the enthalpy. Then we have the change in enthalpy, which may be defined as the amount of heat evolved or absorbed by the system at constant pressure, or it may be defined as the sum of the increase in the internal energy and the pressure volume work done. So this is regarding the enthalpy and the enthalpy change. Now we have the relationship between the del H and del E. Relationship between the del H and del E. Change in enthalpy and change in internal energy. Relationship between the relationship between del H and del E. We know that according to the, हमें पता ही है कि del H किसके बराबर है, क्योंकि अभी हमने इक्वेशन डिराइव की. And we also know that according to the first law of thermodynamics, we have del, according to first law of thermodynamics, del E is equal to Q plus W, or Q is equal to del E minus W. इसको यहाँ लाएंगे तो minus, and for work of expansion we have del E minus into minus P del V, and Q is equal to del E minus into minus, that's plus P del V. And if the process is carried out at constant volume, if the process is carried out at constant volume, that means delta V is equal to 0. So we have QV, यहाँ पर QV is equal to del E. Why? Because del V is equal to 0, so P into 0, that becomes 0, and Q is equal to del E. So it is the amount of the internal energy change, may be defined as the amount of heat evolved or absorbed by the system at constant volume. So at heat evolved or absorbed at constant volume is called internal energy change, and heat evolved or absorbed at the constant pressure, that is called the enthalpy change. So you have here del H is equal to QP, and QV is equal to del E. So we can also say that relationship between the QP and QV. Now we know that इंथैल्पी चेंज किसके बराबर है? इंथैल्पी change we have the enthalpy change del H is equal to del E plus P del V. Clear? Now we know that for ideal gas equation from ideal gas equation PV is equal to nRT. So if we have the volume V1, PV1 that is equal to N1RT, volume and contains number of moles, suppose N1 moles, number of moles of the reactant, and PV2 किसके बराबर है? N2RT, volume and contains number of moles, N2 moles, and that's the number of moles of the products. So N1 is number of moles of the reactants and N2 number of moles of the product. So here if we write this is as delta H is equal to del E plus P into del V is equal to V2 minus V1. So we can write it as delta H is equal to del E plus PV2 minus PV1. So here we are going to substitute the value of the PV2 and PV1. PV1 is equal to this much and PV2 is equal to this. We have delta H is equal to delta E plus PV2 के बदले में यहाँ पर लिखूंगी N2RT माइनस PV1 के बदले में लिखूंगी यहाँ पर N1RT. डेल्टा H किसके बराबर है? डेल E प्लस RT को बाहर निकालेंगे RT इंटू N2 माइनस N1. डेल्टा H किसके बराबर है? डेल E प्लस N2 minus N1, number of moles of the product, final state minus number of moles of the initial state, that's called the del N. So you have RT del N, or del H is equal to del E plus del N G, that's number of moles of the product minus reactant, but they should be in the gaseous state RT. This is the relationship between the enthalpy and the internal energy change. Or we can also write it as delta H के बदले, और delta H के बदले QP is equal to del E QV plus del NG RT. This is the relationship between the internal energy and the enthalpy change. Now, when enthalpy change is equal to the internal energy change, when del H is equal to del E, कब इंटरनल एनर्जी और किसके बराबर होगी? इंथैल्पी चेंज के बराबर. नंबर first point is if we carry out the process at the constant volume, at that time we have the equation delta H is equal to del E plus P del V. अब हमें बोलना है कि ये और ये कब सेम होते हैं, तो उसका कब होंगे ये सेम? when del V is equal to 0, change in the volume that's equal to 0. So if del V is equal to 0, del H किसके बराबर होगा? that is equal to the del E. नंबर सेकेंड, कब होगा ये बराबर? when number of the moles of the gaseous product is equal to number of moles of the gaseous reactant. At that time N2 minus N1 it becomes 0, so RT into del N it becomes 0, and we have the del H is equal to del E. Number second point है when the process is carried out at constant volume, उस वक्त क्या है कि enthalpy change is equal to the internal energy change. Number second, if the number of moles of product is equal to number of moles of the reactant, at that time also the enthalpy change is equal to internal energy change. So if del N is equal to 0, that is gaseous products is equal to gaseous reactants. Then del H is equal to del E. This is the relationship between the del H and the del E. So in today's topic, we have the enthalpy change, and the relationship between the enthalpy and the internal energy change. Relationship between the change in the enthalpy and the change in the internal energy. And in the next video lecture, we are going to discuss what is heat capacity. Thank you so much.